Hey everyone, how's it going? Today I'm solving the week 7 math CA quiz. Let's start. So they give you the curve of an equation, right? And they're asking for the derivative of this equation when you substitute x by 1. So here we're going to start deriving. I've already started. You need to get rid of this denominator. You need to take it up. Okay, we're going to do that by multiplying to the power of minus 1. Now you can see that this is the product rule, right? Because this is u times v. And for the product rule, we need to get like all these. So u is going to be 15, u prime is going to be 0, v is going to be 2 minus 4x to the power of minus 1. V prime is going to be chain rule, so minus 1 times 2 minus 4x to the power of minus 2 times minus 4, the derivative of what's inside here. Okay. Now we could go ahead and start deriving. So this y prime is going to be the u prime times v, okay, 0 times whatever is just 0, plus 15 times minus 1 times minus 4. We can simplify minus 1 and minus 4 is just 4. So that means 15 times 4 into 2 minus 4x to the power of minus 2. Okay, so this is equal to, after simplifying, it's 60 over 2 minus 4x all to the power of 2. Yeah, because there's negative denominator, so we take it down. Now in this, you go ahead and substitute x equals to 1, and you get 15. Okay, part B. A point moves along this curve. As the point passes through point A, the x-coordinate is increasing at a rate of 0.3 units per second, and the y-coordinate is increasing at a rate of 0.5 per second. They want the two values of x. Okay, when you see the rate questions, it helps a lot if you go ahead and start like writing the order they depend on each other. So here the first thing dependent would be y, right? Because if you think about it, what does y depend on? It depends on x. Yeah, because it's y equals mx plus b, for example. So that means the y depends on x, and this x is going to be dependent on, they said here, at a rate of 0.3 units per second. So that means the x increases based on time. So that means the change of y over x, so dy over dx, okay, and this is the change dx over time. If you multiply these two together, you're going to get this derivative here. So that's going to be dy over dt. So an equation we could get from all this is dy over dt equal to dy over dx times dx over dt. Now we can start substituting. So we could see the first thing we need is y over t. So here they told us the y coordinate is increasing at 0.5 per second, so that means y over t. So we could go ahead, 0.5 equal to dy over dx is what we got here. So the derived form, right? We don't want to substitute this because this is x equals 1. We don't care about this. We care about the form it's in. So that means we're going to substitute here 60 over 2 minus 4x. No, sorry. Substitute over 2 minus 4x all squared times dx over dt, so the rate of increasing of x, increasing at a rate of 0.3 times 0.3. Okay, so you take 0.3 to the other side, it's going to be 5 over 3 equal to 60 over 2 minus 4x squared. You can then take this, so 5 over 3, 2 minus 4x squared equals 60. And then divide by 5 over 3 on both sides. So we get 2 minus 4x squared equals to 36. To get rid of this exponent here, this to the power of 2, we take the radical on both sides. So that means we get 2 minus 4x squared is going to be equals to radical 36 is going to be positive 6 or negative 6. It's going to be positive negative 6. Okay, now we'll take both cases. Wait, my bad, this isn't squared. It's outside. Okay, so now we're going to take both cases. So the first case would be this positive 6 is going to be 2 minus 4x. And the second case, minus 6 equals to 2 minus 4x. Here x is going to be minus 1, and here x is going to be 2. And that's what you have. So you got minus 1 and 2. They already wrote minus 1, so here you write 2. Okay, number 2. Consider the function y equals fx. The estimate of the value of f2.02 is given by 1 over 0.02. Okay, so they want an equation. Okay. First thing you should know is that when you have an estimate question, okay, number 2, they give you a function, they want the estimate of the value of f2.02. Okay, when they give you an estimate question, you should know that the derivative, so dy over dx, is going to be approximate to y2 minus y1 over x2 minus x1. Now for y2, y1, x2, x1, to get these values, okay, you're going to want to see here. So the value that you have here is going to be x2, okay, so that means x2 is 2.02, and x1 is just going to be like the rounded number, so that means here would be 2, okay. It's a bit confusing, but just try to take this and try to understand this. In the exam it might be more clear, but who knows. So we're going to start substituting then. So f of x2, right, because y2, f of x2 is 2.02, so that minus f of 2 over 2.02 minus 2. Now to get these values, we're going to substitute 2.02 into the equation they gave us at the start here. So we go ahead and substitute both 2.02 and 2 into this. So here f of 2.02 would be 5 into 2.02 squared minus 2 into 2.02 plus 3. You get a decimal, it's like 19.3624 something, I don't know. And for f of 2, you do the same thing, substitute f2 squared minus 2 into 2 plus 3, you have here, it's 19. Okay, now we're going to take this back and substitute into our formula. So here we go, f of 2.02 is 19.362 minus 19 over 2.02 minus 2 is just 0.02. Okay, now for this equation here, we could substitute this, right? We could put here 19, okay, and 0.02 is the same thing as this, and they don't want you to say f of 2.02. They just don't want you to keep it as 19.36. You just keep it as that. Okay, just don't need to simplify that much. Now for the second part, you could just equate this. So after you do 19.362 minus 19 over 0.02, you get 18.1. So round it up, that's 18. That's number 2. Okay, number 3 is local maximum and local minimum. The first thing you should do is derive the equation. So that means the y prime would be 3x squared minus 6x. And you're going to want to make a table so that everything's easy for you. So x at the top, and you have y prime, and you have y. Okay. So now you need to take this equation and put it to 0, equate it to 0, and you get 2 roots. So after you do that on the calculator, you get x1 is 2 and x2 is 0. So you take both of these values and you put them in the x in ascending order. Make sure they're going upward. Okay, and for these values, the y prime would be 0, right? Because that's what a root is when the equation is 0. Okay, now you're gonna take values before 0. So like for example here I'm going to do -2. In between 0 and 2 I'm going to do 1, and after 2 we'll do 3. Okay, it doesn't matter what the values are, just make sure it's like less than here, less than here, it's in between, and here it's greater than. Okay, so you're gonna take these, substitute them into y prime. You get, so -2, so we'll substitute them over here. So 3 into -2 squared minus 6 into -2. So multiply 3 times 2, all this. Simplify, in the end you get, and here you get a positive number. Okay, again, we don't care about the actual number, we just care if it's positive or negative or what. Okay, and then if you substitute, do the same thing with 1. So 3 into 1 squared minus 6 into 1, you get a negative number. And same thing with this 3 here, you get a positive number. Okay, so that means here we're gonna like draw these lines. It's going up, and then going down, and going up. Okay, now what that means again is that this point here, since it's going up then down, okay, this is a max, right? This point here is a maximum. At what? At x is 0. Okay, so we have a local maximum at x is 0, and here since it's going down then up, we have this is a local minimum, right? This is the lowest point. A local minimum at x is 2. Now that they're asking its value there is, they just means that they want y at x is 0. So you take this 0 and substitute it into our original equation here to get y. In the end you get 13. Okay, number 4. They give you a particle is moving along the x-axis, so that at time t its displacement is an equation. They want the velocity, t1, t2. Okay, so to do this, make your life easier, just derive this. So we know when we derive the displacement equation, we get velocity, and we derive the velocity equation, we get acceleration, right? So here, I'm just going to write them all at the top here. X is equal to t to the power of 3 minus 12t squared plus 45t minus 50, right? This is given, they told us that here. Now if we derive this, we're gonna get the velocity, so 3t squared minus 24t plus 45, and if we derive once more, we get the acceleration, so 6t minus 24. Okay, let's see. The velocity of p is v equals, okay, this is easy, you just substitute in the equation that we got, plus 45, right? This is what we have here. Now given the two values of t1 and t2, t1 is less than t2, for which the particle is at rest. Okay, when they say at rest, that means our velocity is 0, right? So that means we're going to take our velocity equation, equate it to 0. So 3t squared minus 24t plus 45 equals to 0. You get two roots, which I think are 3 and 5. Yeah, do this on the calculator, you get x1 is 3, x1 is 5, and they want it in order like this, so just 3, 5. Okay, the distance of p from O at this point is 3. Now distance, you take the distance equation, so the one they gave us, and substitute 3. So in this equation up here, we're going to take 3 cubed minus 12 into 3 squared plus 45 into 3 minus 50, and you get here, you get 4. Okay, so that means at velocity, at time 3, because we substituted in 3, we get 4 meters away. And you do the same thing with 5, you substitute in 5 into x, you get 0. Okay, all this is just substituting. Now part C, the particle is at the origin when t equals to what and what, and the distance traveled by p between these times is. Now part C, I'll figure out later on, and I'll make a video if I find it. But for now, I'm sorry, I have to skip it though. Okay, number 5. we have another rate question. So first thing I'm going to do is I'm going to start writing the things that depend on each other. So the first thing that depends here is the biggest thing is the volume, which depends on the radius, which depends on time because it's increasing with time. Okay, so v dv over dr times dr over dt is going to be equals to this whole thing, so that means dv over dt. Okay, you're going to want to do this every question, it helps out a lot. The radius of a sphere is increasing at the rate of 4 over pi, so the given is going to be the radius increasing over time. So that means they gave us the radius over time, which is 4 over pi. When the radius is 3, the rate of change of the volume is, okay, so that means we want to find the change of volume per time. Okay, find the dv over dt, right? Because volume over time, you could check also the units so that you don't mix up volume, time. Okay, so let's get our equation. We know that this dv over dt, what we want to find, right, is going to be dv over dr times dr over dt. So dv over dr, we're just going to want to derive the formula for volume. So the shape here is a sphere, right? And the volume of a sphere is 4 over 3 pi r cubed. Okay, if we derive this, we get dv over dr. So to derive it, you just multiply by 3, get 4 pi r squared. So this is our dv over dr, right? And if we multiplied this by what here, dr over dt times dr over dt, we get what we want. So dr over dt is the 4 over pi, so times 4 over pi, we're going to get our final answer, what they want, right? So 4 times 4, 16 pi r squared over pi cancels out, is 16 r squared. Now this, they want us to substitute in, the radius is 3, so 16 times 3 squared, so 16 times 9 is 144. This is our final answer here. Okay, number 6, displacement of an object is given by an equation where x is meters, t is time. The velocity of the object, acceleration. Okay, once again we're going to take our default equation, so x 1 over 3 t to the power of 3 plus 4t, and we're going to derive it once for the velocity, so it's going to be 1 over 3 times 3 is just 1, it's going to be t squared plus 4, and the acceleration we derive again, it's going to be 2t. Okay, doing this helps out with these questions so that you don't get mixed up later on. The velocity of the object after 3 seconds. Okay, easy. You take 3 seconds, you substitute it in this, you get 3 squared plus 4, so 9 plus 4, which is going to be 13. Now part B, the acceleration of the object at t6. So you take the acceleration, you substitute in it 6, 2 times 6 is 12. And then part C, the average acceleration of the object from t3 to t6. When they ask for the average acceleration of anything, so the acceleration average is going to be v2 minus v1 over t2 minus t1. Okay, when we use the equation here, so these three, it's when they want the instantaneous velocity, so the velocity at this specific time, or the acceleration at this specific time. When they want the average, okay, we need to do v2 minus v1 over t2 minus t1. And for velocity average, that would mean x2 minus x1 over t2 minus t1. Don't get these mixed up. So here they're asking of the object from t3 to t6. That means they want the average. right? So now to get v2 and v1, so that we can substitute, we're just going to take these two values and substitute them in our equation here. So from t to the power of 3, I'm going to take here. So v of 3 is going to be 3 squared plus 4, which is equals to 13. And for v of the second time, they gave us a 6. Give us here 6 squared plus 4, 36 plus 4 equals to 40, right? So these are our two velocities. So we're going to take, this is v1, right? This is our first velocity, this is our second velocity. Substitute this into our equation here. The v2 was 40 minus 13 over time 2 is 6, right? 6 minus 3, you get 9. Okay, so that's our answer, is 9. The acceleration is 0 at time equals what? Okay, this is easy. You take the equation for our acceleration. Now they told us when the acceleration is 0, so you just equate it to 0 times 2t. So t is equal to 0. Yes. Okay, number 7. The curve C, whose equation is given by y equals to f of x, has an inflection point at x equals. When they say inflection point, that means that they want the derivative, so f prime prime, to be 0. So that means we're going to have to derive this twice. So f prime of x here is going to be 12x squared, and then f prime prime of x is going to be 24x. So they want this to be 0, x 24x. So that means x is 0. That's it. Number 8 is a local minimum and local maximum question. So we're going to go ahead and do the table, and we're going to do the deriving first. So deriving this equation here, have y prime equals to 6x squared plus 12x minus 48. Right, this is our derivative, and for the table we do x, y prime, y. There you go. Okay, now to get the x values, you equate this to 0. Do this on your calculator, you get the two roots. The two roots for this would be, you get x1 is 2 and x2 is minus 4. Now again here, you need to do these in the correct order. Okay, make sure it's going up in order. If you're going down, you're gonna get the question wrong. Okay, now these are the roots. We take these to 0, and we need to substitute values before, in between, and after. So before we'll do minus 5, in between we'll do 0, and after we'll do 4 or 3 or 17. It doesn't really matter. Again, we don't care about the actual number, just make sure it's in between or after or before. Now we substitute these values into our derived equation. So we'll start off with minus 5. So 6 minus 5 squared plus 12x minus, wait, about here it's minus 5 minus 48, you get, which is 42, so we get a positive number. So here we'll do pos. Okay, now you substitute in 0, you get a negative number, and if you substitute in 4, you get a positive number. Right, it's the same thing as we did here, you're just changing this out with 0 and with 4. Okay, so same thing, substitute. Now let's see what they want here. They already gave us the y values here, so that means we don't actually need to substitute minus 4 into this equation to get y. Okay, they only want the x. So here, a local minimum at what? Okay, let's go ahead and draw our arrows. There. So this here is a local maximum, right? Because it's the highest point. So that means our x minus 4 is a maximum, and x is 2 is going to be our minimum. Yeah, so a local minimum at x is 2, and local maximum at x is minus 4. For part B, they're asking for concave up and concave down. Concave means just the weight pointing, so concave up would be this, okay, and concave down would just mean this. Okay, so this is your graph, and concave down, concave up. That's all it means. Now to find the concave, we need to get f of x prime prime or y prime prime. So again, we had our y prime is 6x squared plus 12x minus 48. So our y prime prime would be 12x plus 12. You're gonna equate this to 0 because we have to use the inflection point we did before, right? So 12x plus 12, 0. So you get 12x equals to minus 12. So x is minus 1. So you're gonna put minus 1, and concave up is gonna, like, memorize this. Concave up is gonna be when x is greater, concave down is gonna be when x is less. Okay, number 9. Here's another rate question. So first thing I'm gonna do is, again, we're gonna do what depends on each other. So the biggest thing we have surface area, so I just write it as A. Depends on what? It depends on the side, and this side is increasing depending on time. Okay, so that means dA over ds times ds over dt gives you the whole thing, which is dA over dt. Okay, so let's see what we have given. The side increasing on time. So they gave us ds over dt, right? They gave this to be 3 centimeters cubed per second. So okay, the rate of the increase of the surface area when the length is 6. So they want the surface area per time. Okay, look at the units. They want surface area per time. That means they want this big thing. So this is easy. We're just going to multiply this by this. Okay, so let's find these two. dA over ds. So the surface area of a cube is going to be 6 times side squared. Okay, if we derive this, we get to dA over ds. So dA over ds is equals to 12s. Okay, and we need to multiply this by ds over dt, which they gave us to be 3. So 12s times 3 is going to be 36s. The rate of increase of the surface area when the length 6, substitute 6. So you substitute 6 into here, 36 times 6, so we get 216. Okay, here's another number 10. They gave us the equation of the displacement and they want the acceleration at time t. So we're gonna start deriving. So v equals to 3t squared plus t, and then the acceleration is gonna be 6t plus 1. Okay, they give us here, they want us to substitute t equals to 2 into the acceleration. So 6 times 2 plus 1 equals to 13. Okay, number 11. They gave us an equation. In the first part, they're asking for the derivative of this. Okay, easy. So you just derive this. You get 3x squared minus 36x plus 81. So 3x squared minus, here, go, 36x, which factors into, okay, you have two options. Here you could either, like, factor it yourself manually, which I will do here. So we'll take it equals to 3 into x squared minus 12x plus 27. Okay, and then this part inside here is identity, which becomes x, which is x minus 9 and x minus 3. Okay, just take the two numbers that add up to minus 12 and two numbers that multiply to 27. This is if you factor it manually, which I think is easier. You could just do this. Okay, So you take here, you have the x minus 3 they already wrote, and the x minus 9 is what they want, so x9. The other option is if you do it on your calculator, you go into the polynomial or factoring on your calculator, okay, and you put in this equation. So you take this, you put in 3 minus 36 plus 81, you get two roots. X1 is 9 and x2 is 3. Okay, and you just like to give this into this form, it's just gonna be x minus 9 and x minus 3. You're just gonna flip the sign. Okay, so you could just do this if you don't have time, but I feel like they're both easy. You could just pick whatever one you want. Okay, now part B. The curve C has a local maximum at x is what, and a local minimum at x is what. Here they gave us a table already, so you can just go ahead and do the arrows here. Plus, plus, minus, plus. And you see here, so this point is the local maximum, this point is the local minimum. So local maximum at x is 3, and the local minimum at x is b, which we got to be here, 9. Here, this question, number 12, you have an equation and you have a bunch of values, right? They want for which values of these the particle is at the origin, so when this is equals to 0, it's equals to 2x minus 15 t squared plus 70. So the easiest way to go about this is just substitute each of these values into our equation and see if you get 0. If you get 0, that means it's an option. If you don't, then it's not. So the ones here that you would get 0 is this, this, and this. All we did again is just substituting. So 2 into 1 over 2 cubed minus 15 into 1 over 2 squared plus 7 into 1 over 2. You get in the end 0, so it's an option. Same thing for 7 and 0. If you substitute one of these, you get a value that's not 0, so they don't count. Okay, number 13. They want to know which ones of these we use in calculating the average acceleration. So we said when we have an average of something, so for here it's acceleration, so it's going to be average acceleration is going to be v2 minus v1 over t2 minus t1, right? So we could see this dv over dt is just a derivative of anything. It doesn't mean anything, so no. The change in its velocity over time taken to cover AB, yeah, that's what this is, the change in velocity, delta v over delta t, right? It's the same thing, so this is correct. This here is the displacement, so this would be correct if it was velocity, but they're asking for acceleration, so this is wrong. It's displacement, this again is the same thing as this, so this is wrong. V, change in v over v, okay, this one, it's correct, yeah, but they're trying to trick you here by, instead of saying v2 minus v1, they're saying tb and ta. So basically tb just means like time 2, right, and ta is just time 1. So that means this is the exact same thing as just saying v2 minus v1 over t2 minus t1. So we choose it, it's correct. And the last option, it's wrong. It's something like dv over dA. It's something like that, but it's wrong. Again, it's a derivative, doesn't have anything to do with anything. Okay, number 14. For this question, they want the interval of the graph decreasing. So we're just going to derive first. It's going to be minus 3x squared plus 27. I'm going to equate this to 0. And we're going to start solving for it. So it's going to be 27 equals to 3x squared. So that you could take 3 to the other side. 27 divided by 3, you get 9 equals 2x squared. And then do the radical 9 equals to x. So that means x is equals to 3 or x is equals to negative 3. Okay, so these are the two roots that we have. Now to find which part it's decreasing, we're going to do the table. Remember the minimum maximum table? We're going to do that. Do y prime y. I'm gonna put in our values. 3 is equals 0, is equals 0. Okay, so we're gonna take any value that's here, so minus 5 for example, and here we're gonna take 0, here is gonna take 5. If you substitute these values again into our derivative, so into this, you get, for minus 5 you get a negative number, for 0 you get positive, and here you get a negative number. Okay, you can go ahead and draw your arrows there. I'm going to clear up the space here. Okay, so now we have our table, and what this means is that for any value that's less than minus 3, okay, our graph is going to be going down, right? So that means it's decreasing for x is less than minus 3, and for the middle part here, it's going to be increasing in between minus 3 and positive 3. So that means it's going up for x between minus 3 and positive 3, and it's going to be going back down for any value that's bigger than 5. It's going to be going back down for any value that's bigger than 5. And they're asking here for decreasing, right? So we're going to take these two. My bad, this isn't 5, this is 3. Okay, so we're going to take these two. Okay, and this, because this is what's decreasing, these are the values of which is decreasing. We're going to choose this option. That's it, because it matches up with what we got. Number 15, this one is memorization. I can't really do much to help you here. It's just these two. Okay, just memorize these two. It's not much to memorize, just like the definition of a point of inflection. Okay, number 16, part A. They're asking for a volume of a cone, and they're giving us the volume of a right circular cone of a base, radius r and height h is given by this equation. A hollow circular cone of height 9 times the radius of the base is held vertex downwards. So that means our height here is equals to 9 radius, right? 9 times the radius is 9r. Now they're saying here they want the volume of this cone based on what we have. So we'll just take this equation here. So 1 over 3 pi r squared times height, we said was 9r. So we simplify, we get 9 times 1 over 3, you get 3 pi r cubed, right? That's the option we choose, 3 pi r cubed. Now part B, they want the volume over the time. So again, we're going to write down this volume depends on our radius, and this depends on our time. So they want dv over dt, which is this whole thing. So that means it's going to be equals to dv over dr times dr over dt. The dv over dr we already have. No, sorry, actually this is just v, right? So we need to derive this to get dv over dr. So I'm going to do this in a different color actually to be more clear. So this derived gives us 9 pi r squared. Okay, this is our dv over dr, so 9 pi r squared multiplied by dr over dt. Let's see, they told us a rate of, well, actually they didn't tell us anything, so they just wanted to keep us as dr over dt. So here we could just write times dr over dt. In the end, it's just as it is, so we choose this answer. Okay, this next part, when the height of the water is 18 centimeters, the radius of the base. Okay, remember they told us the height is equals to 9 times r. Yeah, now they're telling us that the height is 18, which is equals to 9 times r. So r is equals to 2. Now the last part. They told us that water is leaking from the bottom at 4 centimeters per second. That means we're losing 4 centimeters per cubed per second of volume, right? This is our volume, so this is dv over dt is -4, okay? And they want here dr over dt, and from the equation that we get here, the dr over dt, and this is dv over dr, this whole thing is dv over dt. Okay, so from this equation here, we get that the dr over dt is equals to dv over dt divided by dv over dr. Okay, so this is a new equation we got from this. So we have to take dv over dt over divided by dv over dr. Come back here, dv over dt. So we need to divide this by dv over dr. Now dv over dr we actually already have, it's this here, yeah, the volume over radius, so it's the derivative of the volume. So just deriving the formula of the volume again, it's all we have here. So we're going to take this 9 pi r squared. So now we have both of the values, right? So we can substitute dv over dt is just -4 divided by our 9 pi r squared. And they said here that the radius is 2, so it's going to be, it's -4 divided by 9 pi into 2 squared. Okay, after you simplify this, you just do it on your calculator, you get -1 over 9 pi. Okay, last question. So same thing with this question, I'm going to do the volume depends on our radius, depends on our time. So this big one is going to be dv over dt, which depends again, which is multiplied. So dv over dr times dr over dt, right? Because this times this. Now let's see. They're trying to find the rate of change of the radius. It's given by 3 over k pi. Okay, so they want us to find the rate of change of the radius per time, because look here the units. So this is actually what we need to find, and they already gave us this first one, the volume increasing at 3 centimeters per second cubed. So 3 is equals to, now dv over dr is just going to be the derivative of the volume's formula. So the volume formula is 4 over 3 pi r cubed. The derivative of this would be 4 pi r squared. So we take this, substitute 4 pi r squared, and this is going to be multiplied by our dr over dt. So we take this to the other side, it's 3 over 4 pi r squared is equals to dr over dt. And then they said when the radius is 4, so we're going to take 4, substitute it in, so 4 into pi r squared, and substitute 4, this is equals to 3 over 4 pi into 4 squared equals to 3 over 64 pi. So 2k pi is just 64, because this is the part that they want.